Alright, so we're going to take this quiz one step at a time. Um, this first problem, the absolute value of x is here, and there's a 4. Now, almost all of us did this perfectly fine. You're going to subtract 4 from both sides of the equation. Gives the absolute value of x on one side, 6 on the other. I had a lot of students who had some strange arithmetic here, so when you get to your test, take your time, make sure you work through every problem. Now, absolute value gets split into two cases. Case 1 is the negative case. Case 2 is the positive case. So this one has just answers a positive or negative 6. Because there's no more work to do once I've split the two cases. Now if we take a look at number 2, I can go ahead and split this into its two cases because the absolute value is all by itself on one side. So when I split my cases, 3x minus 2 equals negative 10, or 3x minus 2 equals a positive 10. Now I have to solve those two equations. Add 2 to both sides. Gives me 3x is equal to a negative 8. Divide each side by 3. I get x is equal to a negative 8/3. Now the other case, I can say, all right, add 2 to both sides. Leaves me 3x is equal to 12. Divide each side by 3, x is equal to 4. So my answers are negative 8/3 or 4. This next one, when I go to subtract 5 from both sides, I get the absolute value of x is equal to a negative 3. Now, we've talked about this. The absolute value of any number is always positive. You cannot take the absolute value of a number and get a negative. That means there are no solutions to this one. So far in the quizzes, everyone's doing fairly well on 1. We start to lose it on 2, and very few people have gotten 3 correct because you guys seem to have forgotten that core rule. I also want to mention here, remember, the absolute value signs are like parentheses. I cannot go any further until I've split my two cases and gotten rid of those signs. Now, with the inequalities, I can subtract 4 from each side of the inequality, leaving me the absolute value of x is less than 6. So I split that into my two cases. Case 1, x is, the negative case you switch. Positive case, you leave it the same. And since it's less than, I use the word and. When I graph this then, I have an open circle on negative 6, an open circle on positive 6, and it's the space in between. Remember, they're open circles because these are greater thans and less thans, and not greater than or equal to or less than or equal to. Now this one, before I can split my cases, I have to isolate my variable. Absolute value of x plus 3 is greater than or equal to 10. Then, when I split my cases off, x plus 3 is less than or equal to negative 10, or x plus 3 is greater than or equal to 10. Subtract my 3, leaves me 7. Subtract my 3, gives me negative 13. So there's a dot on negative 13, there's a dot on 7, and the lines go away. So take another look at those. They're just like the equations, with the one thing about the inequality sign getting switched for the negative case. It's also important when you guys work these through to isolate the absolute value, get it by itself, then split your two cases, make sure you use the right connecting word, then finish the algebra. Take it one step at a time. You cannot rush these. Now 6 and 7 are the two story problems that come into play. A part is rejected if it is more than, and there's my margin of error, 0.01 millimeters. My requirement is 0.10 millimeters. So when I write this out, remember we wrote this formula. X minus the goal, take the absolute value, some symbol or equals to. In this case, I want more than, and then my margin of error, 0.01. Before I write that, I'll write margin of error for us. That's the formula that we memorized. Guys, that should be on your note card for the final. Please make sure it gets there. So now when I write this out, x minus the goal, 0.1, absolute value bars, greater than 0.01. So now I split my two cases. X minus 0.1 is less than negative 0.01, or x minus 0.1 is greater than 0.01. Add 0.1 to both sides. I get x is less than 0.09, or x is greater than 0.11. So that means that if the part is less than 0.09 or greater than 0.11, it's a rejected part. This area here in the middle that's not filled in as per my inequality, that represents the parts that I keep. Now, part of the trick here, folks, is reading the question and really getting your head around what it's asking. For everyone that drew me an inequality that was filled in the middle, why would I want to reject parts that all are within certain specifications? I want to reject parts that are too big or reject parts that are too small. So you can think about these problems a little bit. When you read it, put yourself in the situation and ask yourself what makes sense for what this question is asking. Take a look at number 7. A casting director wants actors who are within 2 inches in height of the already cast female star. So already I've got an idea that I'm looking for people in a group within certain bounds. And these numbers have to make sense. So I can say, all right, remember what we talked about for these story problems with the absolute values. We talk about within certain bounds. That's kind of your hint that a problem is an absolute value problem. X minus the goal equals margin of error. Now you could write this as an inequality. The problem asks for an equation, and I was fairly lenient with the grading to allow you guys to write an inequality and solve it, but it had to be the right one. You still had to have x minus 67 inches equals 2 inches. I split my two cases, so either x minus 67 equals a negative 2, or x minus 67 equals a positive 2. Add 67 to both sides, I get 65 as a lower bound. Add 67 to both sides, I get 69 as an upper bound. So that means that my bounds are 65 or 69, which works out to be 5'5" or 5'11". And for my students that are thinking about careers in theater, this is part of the process. If they already know who they're going to have in a certain role, they're going to cast somebody that's going to look good on stage with them or on film. And good or bad height can play into that. Two students, now these last two have to do with weighted averages. Two students are unsure how their semester grades are going to turn out. Use the weights of homework at 20%, quizzes at 30, and BAs at 50 to compute their final grades in the class. We had a lot of success on this problem on the quiz. I was very excited to see that. Remember, you take 90 times 0.2 for 20%, 80 times 0.3 for 30%, 75 times 0.5 for 50%. Now, it's important to make sure that your percents have added up to 100, or in this case, to 1. So 0.2 plus 0.3 plus 0.5 is 1. Means I've accounted for all of the weight. And this gives me the values of 18, 24, and 37.5. Add those all up for a final grade of 79.5. You do have to add them up to get the final grade. Just writing these is not a weighted average. This is. So, and actually with the way we round here, this would be an 80% or a B minus. Although some schools will say, nope, 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 that's still 0.5% short, that's still a C+. We do the other students, 75, 70, and 90. Multiply each of those by 0.2, 0.3, and by 0.5 again, same weights. You also notice kind of a reversal here. We have A's and B's on homework and quizzes, C on the BA. Works out to a B- in the course overall. This student has C's on everything, but an A- on the test. So how does that affect his grades? Well, let's see, 15, 21, 45, and that's just multiplying across. 81. And so he also has a B-. And this shows just how much of an impact those grades can be. Now this last problem has to do with the other kind that we talked about, which is what grade do you need, what value has to go into a weighted average to get a specific outcome. It's the one I'm most often asked by students coming into final exam week. So the same kind of a setup, except I'm going to write it, we write these horizontally so it's easier to see. 75% in the first marking period, weighted at 40% of the overall grade, plus 80% in the second marking period, weighted at 40% of the overall grade, plus some unknown grade, weighted at 20%, and our final goal was an 82 in the class. Now I had a lot of students try different ways to approach this problem. Remember, what grade do you need on the final is not the same as what is the weighted average of these scores. So you have to use a different strategy. You can do something involving points and some subtraction, replicate, in other words, remake the work that appears here. It's up to you. But I would be very cautious about that. Go ahead and I crank out my numbers. This is a 30. This is a 32. This is going to be 0.2x. Combine my like terms. Gives me 62 plus 0.2x equals 82. Subtract the 62. 0.2x is equal to 20. Divide each side by 0.2. X is equal to 100. So Zelda has to get a perfect score on her final to raise her overall grade going into finals, which was a C, to a solid B-. She doesn't have a lot of wiggle room. Now, I realize I went through these problems fairly quickly. What you want to do is if there's any problem you're not sure about, go back to that part of the video and take it more step by step. You may even want to recopy the problem on a separate piece of paper, work it out on your own, and then rewatch the video to see if your solution matches mine. Good luck, guys, and we'll see you all in finals.